So you got that, and then this is minus sine squared. So then I told you need a common denominator, right? Because this fraction has a cosine as a denominator, but this one has a 1. So how do I get a common denominator? What should I do? Multiply what? Cosine squared. Good, on the other side. So we're going to multiply this one, top and bottom, by cosine squared. So what I like to do at that point is just write what you see going across. So what I have in my numerator is sine, I'm changing it from x to theta. Let me just bring it back to a theta. So sine squared theta minus sine squared theta cosine squared theta. And that's all over cosine squared theta. Okay. Any questions right now? Because this is really, really important. Like, that's why I extended the due date for homework 10. That's why we're doing a lot of practice. Hopefully it is getting easier. If not, I do say after on Mondays, you need to get extra help. All right. Now we're going to look for a GCF. And I don't know if you noticed that I do have there's a 1 right here. It's invisible. But both of these terms have a sine squared. So I can actually take out the sine squared. And when I take out the sine squared, that's on the outside now. What would I have left inside of the parentheses? 1 minus cosine squared. That's what's left. Which is an identity. 1 minus cosine squared is an identity. And what does 1 minus cosine squared equal? Sine or sine squared? Sine squared. So now, when I replace that, I have a sine squared theta times another sine squared theta. And that's all over a cosine squared theta. Keep in mind that I'm trying to get to tangent times sine. This, what does this equal? Yeah, this is going to change to tangent squared. So I ended with what I was trying to get to, which is tangent squared times sine squared. All right, let's go to our notes. Remember on Friday, I told you that tangent was the cousin that always has problems. So now we're going to do tangent. Tangent has a lot. So I don't know what page we're on, but before I get there, on your pink sheet, these are the identities we're going to work with next. All right, so Friday we did cosine sum and cosine difference, sine sum and sine difference. Now we're going to do tangent. Okay, so now let's find this one. So 7 pi over 12. So remember we said on our unit circle, these are our 3 angles. So this is pi over 6. This is pi over 4. This is pi over 3. So if I'm trying to get a denominator of 12, I'm going to multiply this one by 2, which is going to give me 2 pi over 12. I'm multiplying this one by 3, which gives me 3 pi over 12. And I'm multiplying this one top and bottom by 4, which gives me 4 pi over 12. Okay. So if I'm trying to get 7 pi over 12, what 2 angles am I adding together to get 7 pi?
pi over 3 and pi over 4.
Pi over 3 and pi over 4. So 4 pi over 3, sorry, 4 pi over 12 and 3 pi over 12. So to do this, I'm going to take the tangent and I'm going to add pi over 3 plus pi over 4. This is the bigger angle. This is the smaller angle. So we need to figure out the tangent of pi over 3, which is going to equal the sine of pi over 3 divided by the cosine of pi over 3. So looking at your unit circle, what is the sine of pi over 3? Aisha, what's the sine of pi over 3? Yeah, root 3 over 2, which means this is 1/2. So we're going to do our keep, change, flip. Keep, change, flip. And you should end up with root 3. So the tangent of pi over 3 is simply root 3. Now the tangent of pi over 4, though, that should be easier to find because you're dividing root 2 over 2 by root 2 over 2. So you're dividing two, x and y are the same. And when you divide two numbers that are the same, like 5 divided by 5, what do you think you get? 1, good. So that's the hard part. Well, not hard part, but that's the beginning. You have to figure out the tangent of your two angles. All right, so step number 2 is to substitute. So I'll give y'all a second. Okay, so remember, pi over 3 is alpha. And this is the identity we're working with. We're not doing this one yet. So every place where you see tangent of alpha, I want you to put a root 3. And every place where you see tangent of beta, you should put a 1. So let me go ahead, let me erase some of this. Okay, so let's go ahead and do it. So tangent would be, so that's going to equal, okay, so we have root 3, let me erase this too. So we have root 3 plus 1. Does everybody see what I did there? Let me go here. Notice it says take the tangent of alpha plus the tangent of beta. And we figured out that the tangent of alpha was root 3 and the tangent of beta is 1. Does everybody see what happened there? So all I did was put a root 3 and a 1. And that is going to be divided by 1 minus, and it says take tangent of alpha times tangent of beta. So it'll be 1 minus root 3 times 1. So this is what we end up with. Square root of 3 plus 1 over 1 minus the square root of 3. Now, if you made it to that point, and if it was worth, like, let's say 5 points, you get 2 points. The rest of this is simplifying. So now I'm depending on you going back to algebra 2, because you cannot leave a square root in your denominator. We cannot do that. So in order to get rid of the square root, we have to multiply by the conjugate. And conjugate simply means that you flip this sign. So I'm not going to multiply by 1 minus root 3. I'm going to multiply by 1 plus root 3. Top and bottom. So we got to make some boxes. So for your numerator, go ahead and make a box and multiply root 3 plus 1 times 1 plus root 3. And for your denominator, go ahead and make a box and multiply 1 minus root 3 times 1 plus root 3. So take a minute, fill in all 8 squares. All right, so that's what I got. So these are like terms because they both have a 1. So we can add these together. 3 plus 1 is 4 plus 1 root 3 plus 1 root 3 is 2 root 3s. That's what I have in the numerator. In my denominator, the reason why we multiply by conjugates is so that these can cancel. Does everybody see how that goes away? So then that goes away. So what I have left is 1 minus 3. What is 1 minus 3? Negative 2. If you made it down here, I would be so proud of you, but I would still take off a point because you can simplify it a little bit more. So what this is going to break down is to 4 plus 2 root 3. We're dividing both of these by negative 2. So the final answer that I'm looking for when you take your test next week would be negative 2 minus, you could put the 1, but you don't have to, root 3. So it's a lot more work, but again, you have the identity, so you don't have to memorize it. Now, only because we've already done 60 and 45, we could do 45 minus 30, but I think I'm going to do 60 minus 45 because that's what we did in number 1. We did pi over 3 and pi over 4, and we already know what the tangents are for both of those. So I'm going to do tangent of 60 minus 45. This is alpha, this is beta. So tangent of 60, we already figured out, is just square root of 3. Is the square root of 3. And the tangent of 45 is 1. So this is going to look a lot like the one we just did. So I'm going to have, let me write it out the long way. I'm going to have tangent of 60 plus the tangent of 45 all over 1 plus tangent of 60 times the tangent of 45. That's what I have. So we could just substitute in what we know. So we know that the tangent of 60 is the square root of 3 plus the tangent of 45, which is 1. That's divided by, wait, something ain't right. What did I mess up? Oh, it shouldn't be a plus at the top. What should it be? Yeah, so right here I'm doing this one. It should be a minus at the top. I was about to say, because you never have the same sign top and bottom. So this should be a minus, y'all. Okay, and that's all over 1 plus the square root of 3. So just like before, we got to get rid of our square root. We're going to multiply, but this time we're multiplying by 1 minus root 3. So let's go ahead and make your boxes. That's the numerator. All right, go ahead and fill in all 8 squares. So when you fill in your 8 squares, when you multiply these two, when you add these two together, you get -4 plus 2 root 3. And in this box, these both go away, and you're left with just a -2. But I'm going to divide both of these separately by -2. And my final answer would be a +2 minus root 3. Okay, I'm going to skip over the next question, but I want to go to our next set of identities, which would be, now we're going to look at these right here. Notice that we have 3 different options, though, for cosine. Okay, so let's go ahead and look at this one here. It says they gave us the cosine. This is just regular cosine. And they want us to find all 3 of these. So in order to find these, I need to know the sine of theta, and I need to know the tangent of theta. So this is going back to what we talked about in our first chapter. X squared plus y squared equals r squared. So this is a Pythagorean triple. And when you solve it for y, I'm just going to tell you because of time, y is going to equal 12. So sine is y over r, which would be 12 over 13. Tangent is y over x, which should be 12 over 5. So we got all 3, but we need to know all 3. But there's something really important here. Can you show me with your fingers? If it's telling me to go from pi to 3 pi over 2, what quadrant are we in? Show me with your fingers, where are we at? What quadrant starts at pi and ends at 3 pi over 2? It's in 3. And in quadrant 3, sign is negative. So we got to put a negative in front of that sign. Tangent, though, is positive. So let's get started. We got it. So now let's do our sine double angle. So sine double angle. We look at our paper, at our formula sheet. This is my formula. It says you're going to take 2 times sine times cosine. So 2 times sine times cosine. So 2 times sine, and we said sine was negative 12 over 13. And cosine was negative 5 over 13. So let's go ahead and multiply straight across. So 2, and you don't, so I'm going to go this way. I'm going to do 2 times 5 is 10. And what's 10 times 12? 120. So we end up with a positive 120 over 169. So my sine double angle is 120 over 169. All right, we'll do our cosine double angle, and then we'll pick up at tangent double angle tomorrow. For cosine double angle, though, we have 3 options. We can use either one of these. We can do A, B, or C. We get the same answer. It doesn't matter. I think I'm going to use A. Only because I use A 5th period. All right, so if I use, for my cosine double angle says cosine squared minus sine squared. So cosine is negative 5 over 13 squared minus sine, which is negative 12 over 13. And remember, when you square a fraction, you square top and then you square the bottom. So you have 5 squared over 13 squared minus 12 squared over 13 squared. All right, let's go ahead and see what we get here. When you subtract these, we already have a common denominator, so that's good. So we need to take 144 minus 25. But remember, because I'm taking a bigger number away, my answer is negative. So go ahead and figure out what 144 minus 25 is. Whenever you're subtracting, you always put the bigger number first. But just realize, though, if you're taking a bigger number away from a smaller number, your answer is negative. So I got 119. Anybody else? All right, we'll pick up tomorrow on with tangent squared. We'll do that one tomorrow with a tangent double angle.